No, you're going to get it here in less than 15 minutes.
Well, how long is it going to take?
Not very long.
Speed teaching today?
Well, then
Speed
in that
teaching.
case,
Is the video on from
it
yesterday?
takes
That was
about
gone.
15 minutes to get to my car, so I think I should probably leave now.
Okay, hey, here's the idea. Let's walk through the basics stuff that we have to do here. This is my example today. We're going to use it pretty much throughout the class for this one type of problem. So here we go. Let's go 3x squared plus 4x plus 1. And on the bottom, here we go x squared minus 4. Okay, so this is going to be my problem, right? And the idea, what they want me to do is get a rough sketch where this thing is going. Okay? Now again, this is a super rough sketch. It's not exact, right? It's just a rough scale where we're going. When I look at this thing, I need to know where the tails are going, right? End behavior. I want to know x-intercepts, y-intercepts. I want to know, is it symmetrical or not? Is it one of those things that that I can figure out, is there any horizontal or vertical asymptotes? Because we haven't even talked about that word yet. That was one word I think we wrote on the board last Friday, but we never discussed it yet. Is there any type of turning points that are happening on this thing? Those are like the little things I'm looking at. Okay, so now end behavior. So let's worry about that first. Right, let's get rid of the computer. Thanks. Okay, so on this particular problem, what you need to look at first is end behavior, right? Where are the tails going? Okay, so here's what you need to know. It is a fraction, correct?
Yep.
Yes.
Okay, what I would look at first, I know this seems a little weird, this is it goes with the horizontal asymptote idea, that do you agree that these powers are the same?
No.
Yes.
Like the biggest degrees, they're the same, right?
Yeah.
That is true.
That means, yeah, it's a 2. So the idea is that on this particular problem, it will have a horizontal asymptote. They have the same degree, top and bottom, that we are going to have a horizontal asymptote. And how I know where the horizontal asymptote are is because the powers are the same. You take the greatest or the leading coefficients and you divide these numbers out. What do I get when I divide the 3 by 1?
3.
I get 3, positive 3, right?
Yep.
That's where you're going to have a horizontal asymptote at. It's going to have a horizontal asymptote at 3. That's if the powers are the same. If the bottom power is larger than the top power, right? I don't know what this is. It could be something like this. If the bottom power is larger than the top, then you're going to have a horizontal asymptote at 0. There's going to be one right on the origin because the bottom's too big. And if the top is bigger, you won't have one at all. There will be no horizontals, no horizontal asymptote. That means graphs can go any which way they want. Okay, does that make sense? So that's what I look at first. The reason why I need to know that, you're thinking, why are we talking about that? Is because it affects your end behavior. If you know you have a horizontal asymptote, that's where the tails are going. The tails are they're gonna float right at these spots. They're gonna either float on the top half or the bottom half of these lines. So it's either top or bottom. We'll see where they're going here in a minute. Does that make sense with my horizontals?
Mm-hmm.
Now again, I don't know if it's top or bottom yet. I just know it's in that ballpark. Okay? It's around there. Okay, next. What we need to do next. Now we know kind of where the end behavior of the tails are going. We need to start looking at x-intercepts and y-intercepts because that's going to affect my drawings. Okay, so x-intercepts. Can I factor the top apart?
Yeah.
Yes. It is a trinomial. Most of the problems you'll have today, you'll easily be able to factor. Like there'll be difference of squares, there'll be a trinomial, there'll be stupidly simple ones. This one is probably the most difficult one we probably have today. It's something exactly like this. I'm going to break the 3x squared to be 3x and 1x. The symbol in the back is a plus, so it's going to be the same. They're going to be both pluses, plus, plus. Again, they're the same, they're both plus signs. That's how I look at it. And then I break up the 1 in the back to be 1 and 1. Okay, does that make sense? So now, why I did this? This will tell me where my x-intercepts are. The x-intercepts are what makes the top 0. What makes both of these on the top 0? X-intercept, say it again.
Negative 1/3.
Negative 1/3. There's one of my x-intercepts. And what's the other one? Negative 1.
-1.
Okay, so those are my two x-intercepts. So negative 1/3 and -1. There's my x-intercepts. They're in that ballpark. Okay. I'm drawing. The bottom numbers, when I factor the bottom, that's a difference of squares, these are going to be where vertical asymptotes are going to be. So this is vertical asymptotes. Notice it's not an intercept, it's an asymptote, where you can't cross these numbers on the bottom. If they cancel out, you can. They'll be removable. They'll be just a little dot on the graph, like hollowed. But it would appear when you look at the graphs that it's going right through it. Vertical asymptotes. Can I factor this bottom apart?
Yeah.
Difference of squares. So we can go plus minus, x and x, and then how do we get the 4? What? 2 and 2? So what are my two vertical asymptotes?
2 and 2.
2 and -2. So I'm going to have a vertical asymptote at -2 and another one at +2. So that means my graph is broken up into 3 different pictures. 3 separate pictures. And how I know where they're going to be, it basically comes out to where the vertical, or where the y-intercept is going to be. That'll tell me if this is like going up and down, or is it doing something over here. And then these other ones are like going off it. They're probably like, they're not symmetrical, but they kind of go they go opposites to whatever the middle one's doing, because there's 3 pictures. There's a picture over here, there's a picture over here, there's a picture on this side, and that's what I'm looking at. Okay, does that make sense, like how I'm breaking this picture down? Breaking it into 3 separate pictures. We didn't talk about this the other day. We haven't had a problem where they've had all these different things in it. We've only done like, just where is the random curve going, which is a lot of your homework. But there's like 3 or 4 of them that are like fractions, where we have to break them up. Okay, so now we've done vertical, we've done intercepts, we gotta do y-intercept. How do we find a y-intercept? What was
Plug
the
in
short?
0 for x.
There you go, plug in zeros for x's. X's are zeros, and what you're trying to figure out is where are all the y numbers at. It's the easiest thing in the world. Take your fraction and just plug in zeros into everything. 0 minus 4. So it looks like it's going to end up being 1 over -4. So it looks like my y-intercept is like right here. So what I'm betting on, if I was kind of looking at my graph, and again, I'm guessing where this thing is, to figure out exactly, I'd plug in a few more numbers. But again, I'm just getting kind of a rough scale. I'm thinking it's probably doing something like this. And again, I have no idea. I will look at a graph here in a second. I'm going to show you how you can type this in Desmos to check your numbers. So that's what I'm thinking of.
I wasn't thinking that
Do I remember? We did this last year, didn't we?
Yeah, very similar. Well, we kind of talked about like roughly how you do it. The graphs usually like the left, right, middle, kind of whatever things you have. They usually go opposites in direction. That's kind of the idea. Now, since these are even powers, the tails go the same directions. That's kind of the thing. If they're odd powers, they go opposite directions. So I can kind of get a sense for where the tails are going. That's what I'm thinking of. Now, am I guaranteed? No. I'm roughly thinking this is what it looks like. Okay, because I made it up on the spot, I don't even know. So, let's take a look. So, if I was doing a problem like this on my computer, I would pull up Desmos. So I'm going to pull this up just so you can see this. So, let's see, here we go. Okay, I'm going to pull this up. Okay, now, apologies, this is going to be off to the side. Hopefully you can see this. I'm going to make it a little bit smaller. Okay, so I'm going to type this in Desmos just to kind of see roughly where this is going. And yes, I do encourage you to go on your MacBook, or Chromebook, sorry, and kind of take this in to get a sense for this is going after you're done. You can make corrections, because this is using technology and making sure. So y equals, I'm going to put a fraction, so on the top I'm going to go 3x squared plus 4x plus, 3x squared plus 4x plus 1. I'm going to close that parenthesis. There's a parenthesis there. And then on the bottom, I'm going to divide. I just hit the backslash key, it's right next to the shift. On the bottom, what is that? X squared minus 4. And there you go. Again, how I know where these things are going, I don't. I honestly don't. I just,
Weird.
I'm looking at kind of the numbers they gave me. You know, like where my x-intercepts are, where my y-intercepts are, kind of where the end behavior is going, where the tails are going, and kind of making an educated guess. I know that with an even power, the tails have to go the same direction. They're not going opposites. So I can get a sense for where they're going, where they're flattening out. Seeing where the y and x intercepts were, I can get a sense for, is it curving, is it going down, is it going up? Because if this y intercept would have been going up, like if it had done something like this, I would have expected these to be on the bottom instead, like the outsides are going in opposite directions as the others. Those are like little things you learn over time. But homework today, it was one of those things I wanted to show you, because we haven't talked about this since pre-calc days. Most of the problems are like the problems we've done the last couple days in here, where I just give you a single polynomial, and you're trying to tell me how to graph that thing. Is it going up, is it going down, where the tail's going, can I factor it apart, that type of thing. All right, there's a couple other problems I'm gonna ask you to do in there. They're pretty straightforward, like where you have to try to figure out a formula in a case, just guess what it would be to have a certain situation. I'm gonna give you time today to work. You get a lot of time today. Tomorrow, I'll give you a couple freebies. I'll do a couple on the board tomorrow when you walk into class to see how well you did on some of these graphs. Like if they give you a picture, what would the formula be, or what would the x-intercepts be in certain cases, that type of thing. We'll go through a couple answers that you might have, questions you might have, and then this stuff is due on Thursday. Now, if I don't have you Thursday, it'll be due on Friday. I don't know what days I have you this week, haven't I? It might be Friday. Okay, questions?
Mr. Warden, you got
And then
negative. You got 5 seconds. to end
5
this.
seconds, then you gotta
You
go.
got 5 seconds to end this.
And you're done.